Okay, in this lesson we're going to begin properties of logarithms, more properties. Okay, the first property that we're going to talk about is the change of base property. It looks more complicated than it is. The example hopefully is going to make more sense than this arbitrary property up here at the top. But all we're saying is that if you take the log of whatever's on the inside and divide it by log of whatever the base is, then that's the same as if it's just log base a of that number. All right, so for example, if you do log base 3 of 23, there's no way to write 23 to be 3 to the power of something, right? That doesn't work, all right? So what you can do instead, right, this is going to be a calculator section, right? We're going to use a calculator to approximate this. Now, your calculator, a scientific calculator, does not have the option to write a base, so a base of 3, all right? So what you're going to do instead is you're going to do log of 23, right? That's the big number, and divide it by log of 3, that's the little number, all right? And then that's the exact same thing as if you did ln, right? If I did ln of 23 divided by ln of 3, you would get the exact same number, which is approximately 2.85, all right? Trust me, it'll make sense as you do more examples, right? I think the next page should be more than enough to solidify it, right? So let's just try those now. Okay, so let's rewrite this as a ratio of common or natural logs, and then we're going to evaluate round to 4 decimal places, all right? So this first one, if I have log base 4 of 25, once again, our scientific calculators cannot compute this, right? So what we're going to do instead is make it calculator friendly. I'm going to say that this is log of 25 divided by log of 4, all right? Because hopefully we remember if we don't see a base on a log, it has a base of 10, right? So this is log base 10 of 25 and log base 10 of 4, all right? And the log button on your calculator is automatically a log with a base of 10. But this is also the same as if you did ln, right? If I did ln of 25 and divided it by ln of 4, you would get the exact same number. All right, so I want you guys to plug this into your calculators and see what you get, right? Let me try it right now. To 4 decimal places, we get that this is approximately 2.3219, all right? Got that straight from the calculator, all right? Shouldn't be too bad, all right? We're gonna do the exact same thing with log base 2 of 12. All right, again, your calculator, your scientific calculators cannot compute that, so you're going to do log of the big number divided by log of the little number. If you want to do ln, feel free to do ln, right? It's the exact same thing, ln of 12 over ln of 2. All right, now if you plug this in your calculator, let's see what that gets you. Should get you to 4 decimal places, 3.58, and then it rounds up to 50. All right, so then we get these as our answers. All right, shouldn't be too bad, right? Pretty easy. Okay, so other properties of logs, right? These are the last little properties that you're going to need to know. One of them is the product property. That just states if I have log base a of 2 things that are being multiplied inside of the same log, that's the same as if I were to add between the logs. All right, so for instance, if I have log of 4x, right, that's the same as 4 times x. So this is the same as log of 4 plus log of x, all right? Similarly, if when you multiply, you add, right? When you divide, you subtract, right? If I have log base a of u divided by v, that's the same as log base a of u minus log base a of v. I'm going to use the same numbers, right? Let's do log of 4 divided by x. It's going to be the top minus the bottom. So this is going to be log of 4 minus log of x, all right? And then you also have a power property, which just states that if you have an exponent inside of the logs, then it's just going to move out front and it's going to become a coefficient, all right, or a constant out front, right? This is going to be, like, let's just say, I'm going to use the same numbers, log x to the power of 4. You can take that 4 and you can move it out front, and this is going to be 4 times log of x, right? And similarly, you can go in the opposite direction, right? So you're going to see in the next 2 pages, we're going to have questions that are going to ask you to expand, which means you're going to be given a single log and you're going to want to write as many as you can. Or we're going to ask you to condense, which just means we're going to give you an expression of multiple logs and you're going to use these properties to write it as a single log. All right, and I'll explain what that means in the next few slides. All right. So one thing that we can do in this first one, right, this first one is kind of different from the rest. It just says find the exact value. This is something that maybe we would have given you on your previous test. All you're going to do is convert it, right? I told you guys you can convert this and say that this is 5 to the power of x equals the cube root of 5, and then you guys can cube both sides, and then you get 5 to the 3x equals 5 to the first, and then you can do it this way. But another thing that you can do, right, you get x is 1/3. All right, another thing that you can do is use a power property to simplify this a little bit, right? So we get log base 5 of the cube root of 5 is the same as 5 to the 1/3. All right, I kind of talked about that in the log lesson, right, in the very beginning of it. Now, this exponent, because we have one of our properties of logs, we can move this exponent out front. And this is the same as 1/3 of log base 5 of 5. And then if you have the exact same base, you can cancel them out. And then you're very simply left with 1/3. All right. Again, this example isn't like the rest. As long as you know how to evaluate it, that's fine, right? You don't have to do it one way or the other. This is just an example just to show you guys. All right. Let's try some of these examples, right? If you look at the examples on this page, they just say expand, right? And that just means you're given an expression, one singular log expression, and you want to write as many logs as you can. All right, so what I'm going to do is I'm going to first identify when you're expanding, you're looking for any multiplication, division, or exponents on the inside of your log. All right, so let's look inside of this one right here. Do we see multiplication, division, or exponents? And the answer is yes, right? I see a multiplication in between the 5 and the x to the third, and then x to the third times y, right? That's also another multiplication. All right, and then by one of our properties, I know that that is going to become a plus. And that's also going to become a plus in between two logs. Another thing that I see is an exponent. That exponent is going to move to the front of that expression, right? So let's put it all together, right? When you're expanding, you first want to start with any multiplication and division. So I'm going to turn this 5 times x to the third times y into a log base 4 of 5 plus log base 4 of x to the third plus log base 4 of y. All right, so then that takes care of the plus and that plus. All right, now I want to do something about the exponent. That exponent, one of our properties says that we can move it out front. All right, if you don't move it out front, it's not fully expanded. So you're going to move it out front. And then this is going to become log base 4 of 5 plus this one's going to become 3 log base 4 of x plus log base 4 of y. And then we took care of the front, right, moving that number to the front. So then this is our fully expanded expression. All right, so hopefully you see it's not too bad, right? We have 2 more on this page just to solidify it a little bit. All right, we're going to do the exact same thing, right? You're looking for any multiplication, division, or exponents, right? And I see a multiplication on top, and that's going to become a plus in between 2 logs, all right? I also see an exponent that's going to move to the front, and then I also see division, right? This division is going to become a subtraction, right, between 2 logs, all right? I'm going to do whatever is affecting everything, right? You could go from left to right, but if you look, there's an entire fraction here, right? This whole thing is in a fraction, which means everything is being divided. So let's take care of the division first. All right, to take care of the division, this is going to be ln of 5x to the power of 7 minus ln of y. and that takes care of our division. All right, next thing I want to take care of is the multiplication. All right, so that's going to make this ln of 5 plus ln of x to the power of 7 minus ln of y, right? And that takes care of our multiplication. Next thing I want to do is take care of the exponent, right? So I'm going to move the exponent out front. This is going to become ln of 5 plus 7 ln of x minus ln of y. And that takes care of the exponent, right? So then this would be our final answer. All right. Let's try the exact same thing with the next one, right? Let's see everything that we have, right? I have a division right here. It looks like everything here is being divided. So I know I'm going to have a subtraction over everything on top here minus everything on the bottom here. I also see a multiplication, right? 3 times x to the 4th, so that's going to become a plus. I also see a 12 times y, so that's also going to become a plus. And then this power of 4 is going to move to the front. All right, and it looks like that takes care of all of the multiplication, division, and the exponents. So let's go one at a time, right? The first thing I want to do is take care of the division because that's affecting this entire expression on the inside, right? The entire expression is being divided. So I'm going to take care of that first. This is going to become ln of 3x to the power of 4 minus ln of 12y. All right, and that takes care of the division. So I'm going to check that off. And then I also have multiplication. Right, you always want to do multiplication division first before doing any exponents. So this is going to be ln of 3 plus ln of x to the 4th minus ln of 12 plus ln of y, right? The only thing that you want to make sure of is that when you're reading this from left to right, the way that I wrote it right now, that minus is only affecting the ln of 12, meaning when you add the ln of y and you were to condense it back, that would actually end up on the top. So to make sure that you have the ln of y on the bottom as well, I want to put parentheses around anything that is being divided, right? That's why we do the division first, right? Just so that it's clear that this entire expression that I just wrote in the parentheses is in the bottom, all right? I don't have to write the parentheses on top just because when you go from left to right, the 3 and the x to the 4th, when you condense it, are going to be on top anyway. So there's no need to write parentheses around that. All right. So hopefully that part's clear, right? But that takes care of our multiplication. I can check it. All right. And the last thing I want to do is the exponent. So let's move that 4 to the front. So this is going to become ln of 3 plus 4 ln of x minus, and then everything else stays the same, minus ln of 12 plus ln of y. All right, and that takes care of our exponent, right? Check. And that would be your fully expanded expression. If you wanted to, you could also distribute that negative to the ln of 12 and the ln of y and make it minus ln of 12 minus ln of y. That's perfectly fine, but you can also just leave it like this, right? That's fine as well. All right. Here we have the opposite instructions. All right, here it says condense, right? Condense means to write it as a single log. All right, I want my expression as a single log. Notice in all of these, everything has multiple logs, right? You just want to write it as a single one. All right. So here I would work backwards. I would first do any exponents, and then the second thing I would do is any multiplication and division. All right, so meaning if you have any numbers in front, you want to change them to the exponent. And also if you see any addition and subtraction, then you want to change them. All right, but you always want to do order of operations, right? You see a number 8, you have parentheses, right? We'll get there in a second, but you always want to do order of operations first. All right, so let's look at number 7, right? This just looks like a plain old expression. So what we're going to do is first look for any coefficients. All right, do we have any? All right, yes, we do. I have a 4, which means that that's going to move to the front. All right. The other thing that I see is a minus, which I know that that's going to become a division. All right. But again, one thing at a time, I'm just going to move that 4 to the exponent. So this is going to become log of x to the power of 4, and then minus log of 9. All right, so I took care of the exponent, right? Check. And then next thing is this minus, which we said is going to become division. So that's going to divide everything on the inside here with everything on the inside here, right? So I'm going to put the first over the second, right? So this is going to become log of x to the power of 4 over 9, right? And that takes care of our division, right? Check. And then this is our fully condensed expression. All right, hopefully not too bad. In number 8, we see parentheses around multiple logs, right? So I want to do my order of operations, right? Why don't we first check on the inside of the parentheses to see if there's any coefficients, right? There are no coefficients on the inside of my parentheses, so let's move on to any addition subtraction, right? I do see an addition, that just means we're going to multiply. So let me write that down, right? This just means ln of 3 times x, right? It's whatever's on the inside of the logs being multiplied. So it's ln of 3 times x. That takes care of the multiplication. Check. All right? So then you have now 2 on the outside. Now this 2 has to go over the entire thing. All right, let me use a different color. All right, this 2 has to go over the entire thing, right? So this is going to become ln of 3x to the second. All right, so check, right? We took care of that exponent. Now this is fully condensed, right? We have a single expression, a single log expression, right? It has an ln. If you wanted to, you could also distribute that square to each of these, and you can make this ln of 9x squared, right? That's also perfectly fine. I don't really care, honestly, how you leave it, as long as there's a single log and no coefficients or pluses and minuses. All right. Now let's look at this one, right? Number 9, you do see a parentheses, but this parentheses is just telling you that this whole thing is inside of just this one single log, right? So really there's nothing to condense in this set of parentheses right here. So let's look for everything else, right? See if there's any coefficients. There is in this case, right? I see a 4, all right? That's going to move to the top as an exponent. I also see a minus sign, which is going to count as a division, right? But again, one thing at a time. Let's move the exponent first. This is going to become log of x plus 1 minus log of x to the power of 4. And that takes care of the exponent. Check. And then let's take care of the minus, right? The minus, again, means division. So what does this mean? It just means everything in here divided by everything in here. So this is going to become log of x plus 1 divided by x to the power of 4. So that's that whole thing. We already divided it. Check. All right, that's everything. This is fully condensed. All right, hopefully not too bad. All right, let's try the same thing here. Again, I don't see any parentheses or anything, so I don't have to worry about order of operations. Let's just go first with any coefficients. All right. I see a 3 out front of this log, so I'm going to move it on top of just this 2. So this is going to become log of 9 plus log of 2 to the power of 3 minus log of 3. So we took care of the exponent. Check. All right, now we take care of any multiplication or division. I see a plus, that's going to count for multiplication. I see a minus, that counts for division. But again, when you're doing this for the first time, don't confuse yourself. Just do one thing at a time. So this is going to become log of 9 times. You can replace 2 to the third with 8, right? We already know that 2 to the third is 2 times 2 times 2. So 9 times 8 minus log of 3. All right, and then that takes care of the multiplication. I'm going to check that off. And then we have a minus, and that's going to become division between this whole thing divided by this whole thing. So this is going to become log of 9 times 8 is 72 divided by 3, all right? And then that takes care of division. I'm going to check that off, right? If you have just a plain number, you can simplify it as much as you can, right? This is going to give you log of 24, all right? And then that is a singular logarithm, all right? So that's our idea for condensing. That's how we condense, all right? In this very last page, it looks a little bit different. You're going to use these decimal approximations to evaluate each of these logarithms, and you're going to use the properties that we just learned to do so, all right? So it looks harder than it is. Let's look at this first one, right? Number 11, I have log base 6 of 5 divided by 8, all right? Well, we already know that a divide, that means that we're going to subtract, right? So that means I'm going to subtract 2 logs. So I'm going to expand this, and I'm going to make it log base 6 of 5 minus log base 6 of 8. All right, and that takes care of the division. I'm going to check that off. And they already give us log base 6 of 5 is 0.898 minus, they already give us that log base 6 of 8 is 1.161. All right, you can plug this into the calculator, right? This and the next section are going to be entirely calculators. So you can do 0.898 minus 1.161, and that's going to get you negative 0.263. All right, shouldn't be too bad. Let's try the same thing with log base 6 of 40. All right, well, keep in mind, you're going to be using the log base 6 of 5 and the log base 6 of 8 somewhere in this computation, right? So think, what's one way that you can write log base 6 of 40 using a 5 and an 8, right? And 5 times 8, as you know, gets you 40. So you can write this as log base 6 of 5 times 8. All right, and then you know that one of our properties of logs is that multiplication becomes a plus. So this is going to become log base 6 of 5 plus log base 6 of 8. All right, and then once again, you would use the decimal approximations that you were provided with to find this answer. All right, this would be 0.898 plus 1.161. All right, plug this into the calculator. All right, these are fairly simple numbers. You should be able to do this by hand, but we get 2.059. All right, hopefully we know how to add and subtract decimals. All right, now let's try the same thing with the next one. All right, I have a log base 6 of 64. All right, there's a couple ways that you can go about this, right? Again, keep in mind, you're going to use either the 5 or the 8 somewhere in this computation. All right, log base 6 of 64 is the same as log base 6 of 8 to the power of 2. All right, we know that 8 squared is 64. Another thing that you can say is that this is log base 6 of 8 times 8. So you have a choice here, right? We know that 8 squared is 64, so you can use a power property to move this 2 out front. And then you're going to get 2 times log base 6 of 8. Or you can use this property of multiplication and make this log base 6 of 8 plus log base 6 of 8. Right? Both of these are correct, right? One is not better than the other. I'm going to do the exponent one just to make it a little bit different from the others, right? So we have we have 2 times log base 6 of 8. This is the same as 2 times 1.161. All right, again, that's a number that we were provided with. And when we do this, we're going to get 2.322 as our answer. All right, and let's try the exact same thing with the last one, right? Again, 125, we can somehow write that using a 5 or an 8. And hopefully you guys know that 125 is the same as 5 to the power of 3. So this is the same as log base 6 of 5 to the power of 3. And then just like the previous one, you can move that exponent out front, or you can write it as log base 6 of 5 times 5 times 5, but I would rather keep it a little bit simpler and move the exponent out front and just multiply that number instead. So this is going to get us 3 log base 6 of 5. And again, you're going to use the number that you were provided with, right? This is 3 times 0.898. And then when you plug this in, should get you 2.694. All right. And that's really it for this lesson, right? It shouldn't be too hard. These properties are going to help us a lot in the next lesson when we solve exponential and logarithmic equations, right? Because you're going to encounter some log equations that seem kind of tricky, but properties can help make them a little bit simpler. All right, but that's it for this lesson.